Hello students, welcome to my channel. My name is Darshan. I am your maths prof. So we have already done the questions, paper 2 type style of questions of the whole first chapter. I have covered all the topics of the first chapter. Now from this session we'll be starting the calculator kind of questions now. So here we'll solve all the questions which you can expect in the paper 4. Let me remind you, in IGCSE extended there are two papers which you are gonna attempt. First one is the paper 2, which is 100 marks long, and that is non-calculator, and another is paper 4, that is calculator paper, and that is also 100 marks. So both have the equal weightage now. Okay, so in this session we'll see classification of numbers. That is the first topic of the numbers chapter, and we'll see two worksheets of that, and we'll use calculator in this kind of questions. Okay, so let's start the first worksheet. See the first question. Here the list of numbers are given, and from this list write down the number that is a multiple of 3. Now, as you already know that this is the calculator kind of question, so you can simply use calculator to find whether they are divisible by 3 or not. But from the list I can simply say that 12 is divisible by 3. Others are not divisible by 3. You can also check using this calculator. 12 divided by 3, you can see on the left hand side of the screen I'm using the calculator, and that is 4, so it is exactly divisible by 3. So 12 is the multiple of 3. Next is a cube number. From the list we can simply say that 8 is a cube number because you can find the cube root of 8. Let's check this. 8 to the power, cube root is power 1 by 3, so I'll write 8 to the power 1 divided by 3 in the bracket and bracket close. So this is 2, so that means cube root of 8 is 2. This is why 8 is a cube number. Similarly, a prime number, which we have already done in the explanation part, that 5 is a prime number. Okay, and how to find the prime number from the list of the numbers which we have already covered in that session. If you haven't watched it, go and watch it. It's very useful for you. Then comes the irrational number. Now let me tell you irrational number. First, what is rational and what is irrational? Rational means you can convert it into p by q form, that means a fractional form, and irrational means you cannot convert it into p by q form. In simple word, if any decimal which has non-terminating and non-recurring kind, that means it doesn't stop or it doesn't repeat the same pattern, that is called irrational. As well as square root of non-square number, cube root of non-cube number, all are called irrational. Now this 3.56, because it's terminating decimal, you can easily convert it into p by q form like this, 356 upon 100. So obviously it is rational. 5 can be written as 5 upon 1, it's in p by q form, so obviously it is rational. 196, square root of 196, see on the left hand side of your screen, that is square root of 196, that is 14, and 14 can be written as 14 upon 1, so yes, it is rational. 8 is also written as 8 upon 1, so it's rational, and 12 is also 12 upon 1, so it's rational. Only 7, square root of 7 is left, which is irrational because 7 itself is a non-square number, and square root of non-square number is irrational. This is why square root of 7 is irrational. Clear? Let's jump to the second question. Write down the prime number between 50 and 60. So that you can find in that my first video of classification of numbers, where I have already given you all the prime numbers starting from 1 to 60, and I have shared you the method also how you can find the prime numbers from the given list of numbers. Now between 50 and 60, if you see, 53 is a prime number, so 53 I can write it's a prime number. Now write down a prime number between 20 and 30. So between 20 and 30, easily you can say that 29 is a prime number, 23 is a prime number. So you can write down any one. Because they are asking a prime number, always go with only one answer. If they are asking you only one, then just give them one only. If you are giving them more answers, then it might considered as a wrong answer. So that means the answer is here 23, or you can also write 29. Don't write 27. 27 is not a prime number. Okay, that was it in the first worksheet. Let's see the second worksheet now. Paper 4 style, that means with calculator. See the first question. 1, 2, 3, 5 and 7 are all common factors of two numbers. That means there might be some numbers which have these common factors, right? That means the two numbers which they are talking about, they have HCF is equal to LCM of these all numbers, right? Because all those two numbers are multiples of 1 as well as 2 as well as 3 as well as 5 as well as 7. So I will first find the common multiple of all these numbers. If you find the common multiple of all these numbers, for that you can do the prime factorization. 1 is just 1 only, no prime numbers are there. 2 itself is prime, 1 is just 1, 2 is a 2 raised to 1 only, 3 is 3 raised to 1, 5 is also 5 raised to 1 and 7 is also 7 raised to 1, because all are prime except 1. Now to find the LCM, you just multiply all of them. So on the calculator, see this, 2 times 3 times 5 times 7, that is 210. So the numbers they are talking about, they'll be multiple of 210. Okay, and any number who is the multiple of 210 will always have 0 in its end, right? Because 210 itself is ending in 0. That means if you find any multiples of 210 will end in 0. So write down the digit that the two numbers must end in. So that digit is nothing but 0. Clear? See the second question. Insert a pair of brackets to make this calculation correct. Now this type of question, which is 1 mark question only, you don't need to show any method for this. Any 1 marker question, you don't need any method. And specifically this question, it doesn't have any method. You just try out different pairs of brackets at different places in the equation and check whether LHS is equal to RHS or not. That means it's just trial and error method. So I already know the answer, so it will be here only, because if you see this LHS, if you solve, that is 7 minus 5 minus 3 will be solved first because it is inside the bracket according to BODMAS rule. So this 5 minus 3 is 2 only and plus 4. Now according to BODMAS rule, first these two will be added and then we'll subtract the 2, because in BODMAS addition comes before the subtraction. So this 7 plus 4 will become 11. 11 minus 2, that's 9. And if you see the RHS, RHS is also 9, right? It is RHS, sorry. So RHS is also 9. So I'll write RHS here. So that means this pair of bracket is correct. Now see the third question. Explain why square root of 3 is irrational. Now that is also 1 marker question. They just need a statement. You already know that 3 is a non-square number and square root of any non-square number is irrational. But what to write as a statement? So the statement you can write as the decimal expansion of square root of 3 is non-terminating and non-recurring. So it cannot be written in P by Q form. That means fraction form. You can also check using this calculator. If I'm finding square root of 3, you see it's showing up to a few digits only, but you see it's not gonna end there, as well as you can see it's not repeating the same pattern. So it is non-terminating and non-recurring. See the fourth question now. Tom is telling a wall he needs to buy at least 100 tiles. The tiles are sold in large packs and small packs. Large pack contains 40 tiles and the large pack costs 18 pound, and small pack has 28 tiles in each and it costs 14 pounds. The special offer is, if you if you buy 3 or more large packs, then 25% discount will be given. Clear? Work out the cheapest cost for the Tom to buy the packs of tiles he needs. Now he needs at least 100 tiles. So he has options. Either he can go for 3 large packs. 3 large packs will be 40 times 3, that means 120 tiles, which will contain more than 100 tiles. Or he can go uh, uh, 2 small and 1 large, or let's say all the smalls also he can mix and match. So let's take the worst case scenario. The maximum he can buy is large packs of 3 pack. That means if he's getting 3 or more large packs, then he'll get discount also. So let's check after discount what will the cost. So what I'm doing, I'm finding the first before the discounting the total cost. So cost before discounting. By the way, I'm first finding the scenario where he's buying 3 large packs. So let me write it here only. So for 3 large packs, so cost before the discounting is 18 times 3, that is 54 pounds. You can see in the calculator, that is 18 times 3, that is 54. Now out of these 54, there will be 25% reduction. So let's find that reduction, or you can say discount. So discount is equal to 25% of 54. So let's find it out. 25% is 25 into 54 divided by 100. So that is 13.50 pounds. Don't write 13.5. This is a currency. Currency should always be in 2 decimal places. So now after the discounting, final cost will be 54 minus 13.50. So 54 minus 13.50, that will be 40.5. So 40.50 will be the cost if he buys 3 large packs. Now let's take the minimum order he can do. That will be if he's buying small packs of, let's say large packs of 2. So that will be 40 tiles, and then he buys a 1 small pack. In that case he'll not be able to get the discount. But of course, let's find the cost for that. So for 2 large packs and 1 small pack, because for the 2 large packs he'll get in 2 large packs he'll get 14 to 2 80 tiles there, and 28 tiles more. So 80 plus 28, 108 tiles. So at least 100 he already has. So now this cost, final cost only, because no discounting will be there. So 2 times the cost of large pack, that is 18. So 2 times 18 plus 1 times 14. So let's find it out. 2 times 18. Don't forget to put the brackets here also in calculator. 1 times 14. So that's 50 pounds. And if you find any other mix and match, it will be more than that only. So the most efficient will be 40.50 only. So this is how the cheapest cost is. Sorry, it's 40.50. Put all the currencies in 2DP. Again, I'm telling you, it's IGCSE rule. And see the B part. Tom is also telling a floor. The floor is rectangle with length 600 centimeter and width 240 centimeter. Each tile is a square with 40 centimeter length. Tom uses this method to work out the number of tiles he needs. The number of tiles that will fit along the length will be 600 divided by 40, which is 15, correct. And number of tiles that will fit along the width will be 240 divided by 40, that is 6. And now he's doing total number of tiles. This is 15 plus 6, that is 21. That's wrong. That's wrong. I'll tell you why. Because if there are 15 tiles in the length, I'm sketching one rectangle here. Imagine there are 15 tiles in length. So like this, 15 are like this. There are 15 such tiles. And here he'll take 6 such tiles. 5 and 6. Now the total number of tiles are not 6 plus 15. It's 6 times 15 now. Because in each row he'll put 15 tiles. So 15 in the first row, then 15 in the second row, then 15 in the third, 15 fourth, 15 fifth, and 15 sixth. So 15 times 6 if you find, you will get the total number of tiles. So give the reason why Tom's method is wrong. Because the total number of tiles is equal to 15 times 6, not 15 plus 6. 15 times 6. Let's do on the calculator. 15 times 6, that is 90. So total tiles needed are 90, not 21. Clear? Okay, that was it in this session. In the next session, we'll see the calculator kind of questions based on HCF and LCM topic. I hope this is helpful. If you find the videos helpful, just give me a thumbs up, give me a like on this video, and give us a comment. It will motivate me. Thank you very much.